Okay guys, we will continue the concept of atomic radius. Here guys, to find an atomic radius, it is what somewhat very difficult to find an atomic radius of an atom. Okay, here to isolate an atom, that is what a major thing here, that is what a too difficult concept to isolate an atom from its molecules or any other compounds. Okay, the atom means it consists of nucleus and an electrons, right guys? Here atomic radius means what? The distance from the nucleus and its outermost orbit. Okay, the distance from the nucleus to its outermost orbit is called as what? An atomic radius. But here to determine this radius or a distance is very difficult. Okay, because in an atom, the cloud of an electrons will surround your nucleus. Okay, this is called as what? And clouds of electron that will surround your nucleus. So that here a particular sharp edge of the cloud of the electrons will not be there in an atom. Okay, if you consider this as an atom, means this is what? A nucleus, and this is what? A sharp boundary of this atom, and this sharp boundary will not be present in your atom. These kinds of the sharp boundary is not there for your atom, and so we can't find the distance from the center of the nucleus to an circumference. That means what? An outer orbit of your atom. Okay, to get at this radius is difficult because there is no sharp boundary for the electrons which is present in an atom. Okay, that means this is not like this sharp boundary, this is like what? And clouds here, clouds like structure here, and so electrons can move in this orbits. Okay, this is like structure here guys, and so we can't have a sharp boundary to calculate the distance from the nucleus to an outer orbit. Okay, so that we doesn't have a practical method for the calculation of the radius of the atom. Okay, because there is an absence of the sharp boundary for the atom. Okay, there is no sharp boundary for your electron cloud that will surround your nucleus present in an atom. Okay, so that then how we guys will find out the radius of an atom? That is what I next important concept, because we doesn't have any practical method for the calculations of the radius of an atom. So we will consider the simple thing here, the distance between to calculate radius of an atom, we will consider distance between the two atoms which are bonded by a single bond. Okay, if these two were the atoms, and these two were bonded by a single bond, then the half of the distance between these two is considered as an atomic radius. Did you got this? Here there is no sharp boundary exists between the atoms, and so we can't calculate the radius of an atom. So technically we will solve this kind of the complications by a simple thing here. We will combine the two atoms. With a single bond. Then we will measure the distance from the atom 1 nucleus with an atom 2 nucleus. Okay. Then the half of the distance between these two nucleus is considered as an atomic radius. Why we can't calculate atomic radius for a single atom? Because here there is no sharp boundary for the electron cloud which surrounds the nucleus. Okay, so we doesn't have a sharp boundary, means we can't calculate the distance from nucleus to an outer electrons orbit. Okay, so we will just simply make a bond between the two atoms, single bond, and calculate the distance from the nucleus of one atom with the nucleus of other atom. The half of its distance is called as what? An atomic radius. For example, guys, if you consider an Cl2 molecule, for example, if you consider an Cl2 molecule, here guys, there were 2 chlorine atoms. Is it right? Here it consists of 2 chlorine atoms. Okay, the nucleus of one chlorine and an electron cloud, and again the nucleus of another chlorine and an electron cloud. Okay, here this is also one chlorine atom and this is also another chlorine atom. Okay, here guys, the distance from the nucleus of one chlorine and the distance between these 2 chlorines will be measured. Okay, these 2 distance will be measured, and to calculate the atomic radius of this chlorine atom, then we have to take the half of the distance between the nucleus of 2 chlorine atoms. Half of the distance between the nucleus of 2 chlorine atoms. That is considered as an atomic radius of a chlorine atom. Okay, did you got this guys? For example, if your chlorine, if it is single bonded means it will have a distance of 198 picometer. That means what? The distance from this nucleus to this nucleus is around 198 picometer. Did you got this? Yeah, pico means what? 10 power minus 12. 10 power minus 12 meter. Okay, the chlorine to chlorine atoms distance is around 198 into 10 power minus 12 meter. Okay, to get an atomic radius, what we will do? We will take an half of the distance between these 2 atoms, means divide this by 2. Then what is your answer? Atomic radius for a fluorine will becomes what? 198 half divided by 2 means what? Here 99 picometer. 99 picometer. You got this? Now this is what the distance or an atomic radius of your single chlorine atom. Okay. Here you know that guys, here this chlorine is a non-metal. Chlorine is what? A non-metal element. Chlorine is a non-metal element, and these non-metals will forms an covalent bond between each other. This will forms an covalent bond between each other because this element is a non-metal. Okay, and so that because of presence of covalent bond between the 2 Cl atoms, we will call the atomic radius of chlorine as an covalent radius of an chlorine. In generally, we will consider the distance between these 2 chlorine atoms as an what? Covalent radius of an chlorine atom. Instead of atomic radius, here we consider an covalent radius because these 2 chlorine atoms will form an covalent bond in between these 2. Okay, because these were non-metals. Okay. For example, sir, if you consider a metallic element, for example, if it is a copper means here guys, copper, here 2 copper atoms were bonded together, and this becomes what? An atomic radius of your copper. You know that here this copper is a metal means how we will calculate the atomic radius of copper? There, here in metals, the copper atoms will arrange in 3-dimensional space. These copper atoms will arrange in 3-dimensional arrangement. Okay. The distance between the 2 copper atoms, in a crystals or in a crystal lattice we will call. Okay. Yeah. The distance between the 2 copper atoms present in the crystal lattice is called as what? An atomic distance between these 2 copper atoms. And if you want to calculate the atomic radius, means what we will do guys? Atomic distance divided by 2. That will give out what? An atomic radius for you. Okay. For example, here your copper will have around 256 picometer. picometer as an atomic distance. Atomic distance means what? The distance from the nucleus of one copper atom to the nucleus of other copper atom. Your copper atom will have the atomic distance of 256 picometer. Okay. Here, to get an atomic radius, what we will do is atomic distance divided by 2. Then atomic radius is equal to 256 divided by 2. Then your answer is what? Atomic radius is equal to 128. Right? 128 picometer. Did you got this, guys? This is how we will calculate the atomic radius. Here, this is an metal. So, in the form of non-metals, the distance between the atoms were considered as an what? An covalent distance, and the radius of the each atom is considered as an covalent radius. Whereas here the element is metal means the distance between the atoms were considered as an what? A metallic distance, and the radius of an atom is considered as metallic radius. It is considered as a metallic radius. If the element is metals, if the elements are metals, then you guys were calculating the radius of the atom means, or a metal atom means, that will be considered as a metallic radius, because in the metals there is an formation of metallic bond. Okay, whereas in non-metals the elements are joined by a covalent bond and the radius will be taken as covalent radius. Whereas in metals, the metals were bonded by a metallic bond and the radius is considered as a metallic radius. Okay guys, we are in our complete chapters. We will consider for both covalent radius and your metallic radius as an atomic radius. Okay, your atomic radius means what? Covalent radius, and also your metallic radius will include in atomic radius. If the element is a non-metal, then this will have an covalent radius. This one is also considered as an atomic radius. If the element is a metal, then the radius is considered as a metallic radius. And again, in your chapter, this metallic radius is considered as an atomic radius. Okay. Throughout your first PUC, we will consider the covalent radius as atomic radius only and metallic radius as atomic radius only. Only the difference is what? Covalent radius is for a non-metals and metallic radius is for the metal element. And both these two will be considered as an atomic radius. Okay. Did you got this, guys? This is about what? How we will calculate the atomic radius of an element. If it is a non-metal, that will be considered as a covalent radius. And here in our complete chapter and in our complete first PUC, we will consider covalent radius and your metallic radius as an atomic radius. Okay. This is what and complete picture to calculate how we will calculate the atomic radius. How we will calculate atomic radius of the elements. Okay.